Hello and welcome. My name is Ahmed Hussein, and today I will present my topic in the WDBE Virtual Summit 2020. My topic is about how to utilize life cycle assessment using building information modeling during design phase. It's sponsored by Skanska, and I did my master's in construction management between HTW University in Berlin and Metropolitan University in Finland. The introduction is briefly, climate change has recently gained massive attention worldwide. The building industry causes 40% of the global greenhouse gas emission. Finland aims to achieve carbon neutrality by 2035, and Skanska target to be a net zero carbon emission company by 2045. The Ministry of Environment in Finland have produced a low carbon construction roadmap to include carbon assessment in the building permits in the 2020s. And this is related to the United Nations Sustainable Development Goals, goal number 11 and goal number 13, climate action. Life cycle assessment is one of the most widely used methodology for evaluating the product environmental impact during its whole life cycle. Building information modeling is the process and technologies used to create a digital building model that represents the building information efficiently. BIM or the national BIM requirement in Finland has been issued in 2012. It defines the minimum material information content in the design models, and it consists of 13 series and 4 appendix. This research highlights the benefits of the employment of BIM in the building lifecycle assessment process during the early design phases. That would help designers and architects to consider environmental perspective in their decisions. Why in the design phase? As you can see from this graph, the blue curve represents the effort or ability to make any change for the project. It's very high in the early phases and it gets much lower in the end of the project. While the red curve represents the cost of implementing any change to the project. The cost at the beginning of the project is pretty low to implement changes, and it gets very high at the end of the project. Then the best time is making changes or considering to make any environmental aspect changes in the early design phase. Also, the thesis conclude a modification to the COBIM to be the new industry environmental standardization and the foundation for an automated LCA process. The thesis illustration in the LCA calculation development time frame shows like this. Now, the usual current process of LCA takes 2 to 4 working days, and it involves 3 departments. The cost control department, who make the bill of quantities, for example, and material building information, send it to the environmental department, who calculates the carbon emission and send it back to the designer, who take decisions to change the material to a low carbon materials. That's pretty complicated and takes too much time. The thesis attempt is just extracting the building material information from the design models through Solibri, through a BIM software, and insert it in the LCA calculation tool. That will take approximate time 1 to 2 working days, and it involves 2 departments only, not 3, environmental department and the designer. And the future process would be that conducting the LCA calculation in the same design software, in the same Solibri, for example, or any other BIM software. That will take 30 minutes per project, and the designer himself will do the LCA calculation. Case studies that has been applied in this thesis. So we'll take IFC model in Solibri and extract the Excel sheet out of them. The IFC model in Solibri already follows the COBIM in Finland. So after extracting the Excel sheet, we'll put this material information, building material information in the carbon assessment tool, like for example one-click LCA, and get the carbon emission based on the Ministry of Environment method. It's very crucial at this point to clarify that this thesis aim to modify the process or investigate the opportunity to enhance the process using BIM, but not investigate the credibility of the tool, for example, or any other, or fix the IFC models if there is something wrong with the design. So the methodology briefly will apply case studies to propose this BIM approach, and then we will analyze the case studies, obstacles and problems, and then we'll make a comparison between the co-BIM and the Ministry of Environment method to have some future modification to the new environment, to be a new environmental standardization. So the case studies, we have 3 residential building from Skanska, Finland. We have the models for architecture and structure designers, and as well as like very rough estimation in the very early design phase. Anyway, this photo shows in the left side the architecture model. It shows the non-bearing elements, exact material information, and in the right photo shows the structure model that shows the bearing material information. As we can see here in the structure, it shows the foundation, but the foundation doesn't show in the architecture. So from this, we can conclude that we extract the material Excel sheet from both models, and we combine them together and start calculating the carbon assessment. Because, for example, here in the structure model, it shows the exact information for the bearing elements like foundation, slabs, walls, columns. What I mean by exact information, that the material names and volume, and that's the most crucial part for calculating the carbon assessment. While in the architecture model, it shows other non-bearing elements like windows and doors. So we did the carbon assessment for the case studies, and that's the second case studies as well. We make a comparison between different models and different design stages, and the third case study. And the conclusion out of the case studies that it took too much time, as the main obstacle was 3 filtering phases. First, there was a manually filtering from the Excel sheet extracted from the building information model, and the second filtering was auto filtering phase by the LCA tool. And the second one was manual allocation of exact material, and that was the most time consuming, because if you don't have or if the designer didn't specify the exact material information, then we will contact the project engineer or the designer back again. I mean the environmental, or the one who conduct the carbon assessment, will have to contact the project engineer or the designer to know the exact information, and then allocate them in the LCA tool to get the carbon emission out of it. And we concluded from here that we need a standardization from this for the industry to make automated life cycle assessment. We made an Excel sheet as a comparison between the co-BIM and the life cycle method. Briefly, this Excel sheet, as it shows, it combines the different series of co-BIM, and they both have that's the Ministry of Environment material, related material, and that's project classification 2000, Tallo 2000 in Finnish language, and project classification building 2000. That's classifies the project. And then here is the co-BIM 3, here is the co-BIM 5. It specifies the minimum information in each category or each class in the building. Co-BIM 7, quantity takeoff, and then appendix annex for architecture design, and another annex for structure design. It shows you which kind of information should be specified in the model. As co-BIM has been initiated in 2012, it doesn't have any environmental consideration. So, for example, some materials doesn't have to be mentioned the volume out of it, and that's a huge mistake for or a huge obstacle for calculating the carbon emission from the model directly. So fixing these problems will help to make an automated life cycle assessment process. To go back for so the conclusion that calculating the building carbon assessment is still a very complex process due to the current data management between different stakeholders. The generated Excel sheets represents a foundation for automated LCA process. It highlights the environmental shortage in the current COBIM, and the COBIM must be updated to include environmental consideration in all engineering discipline. Designs like material name and volume must be mentioned. To achieve an environmental building permit, standardization is essential in the building industry. Like example, using GTIN code for any products, any construction products that shows you the whole carbon for this product from the extracting the raw materials until the construction or until the end use. The carbon designer tool was pretty good. That should be further development, and that's the reference. And thank you so much. I hope you enjoyed the presentation, and sorry that I have presented pretty fast. I had a time frame.